Okay, this is a really hard question. Lots of things happening in this. Cylindrical water tank of height 2 meters is placed in the ground. The radius of the tank is 3.78. The hole is 2 meters deep, and when the tank is placed in the hole, and there is a 1 meter gap all the way around. So the first one, when digging the hole for the water tank, what volume of soil was removed? So what sort of shape is this hole going to be? It's going to be a cylinder. Now, the radius is not 3.78. The radius is 4.78 because of this extra 1 meter, and the height is 2 meters. So the first thing we have to do is find that formula. On the formula sheet, volume equals pi r squared h. Volume equals pi r squared h, where r is 4.78 and the height is 2. So the amount of dirt moved, and it's just straight substituting it in, 143.56 meters cubed. Okay, I'll give your answer to the nearest cubic meter. To the nearest cubic meter, that would be 144 cubic meters. So make sure you read the question, go back. 3-mark question. I've done it fairly quickly. There is a bit of issues there. The rest of it's not too bad. Sprinklers are used to water the school oval with a rate of 7,500 litres per hour. The water tank holds 9,000 litres when full. For how many hours can the sprinklers be used before a full water tank is emptied? In other words, it starts with 90,000 litres and it's using 7,500 litres an hour. Basically, what we're asking is how many 7,500s go into the 90,000. But this is how I've done it. I've said that 7,500 litres equals 1 hour. We want to know how long it would take for 900 litres to be used. Now, I've set it up like this. I like setting them up like this. I think it makes sense to me. I'm going to use what's called the unitary method. So in other words, what I'm going to do is I'm going to take it back to 1 unit. Now, because I've set it up this way, I know that I've set it up 7,500 litres equals 1 hour, 90,000 litres equals what? So how do we go from here to here? We divide it by 7,500. If we do that to the left-hand side, we're going to divide this by 7,500. Then how do we get from, if 1 litre takes this amount per hour, how do we get from 1 litre to 90,000 litres? We're going to times this by 90,000. So we're going to times this by 90,000. This just makes sense to me. This is the way I think it makes most sense to set it up. And what we get is 12 hours. What you should understand is that 12 times 7,500 equals the 90,000. Or you could have just straight away gone 90,000 divided by 7,500 and you got 12 hours. So that would have been nice. Either way. The last question is a bit harder. It's like a band 6 question. These first two weren't too bad, maybe a band 3, band 4 type idea, but this is definitely a band 6 question. The reason why is that you have different units happening here. So question 3, water is to be collected in the tank from a roof on the school hall, which has an area of 400 metres squared. During a storm where 20 millimetres of rain fell on the roof and is collected in the tank, how many litres of water were collected? So this has nothing to do with the cylinder anymore. It's only about how much water fell on this roof. And the roof is 400 metres squared and the rain is 20 millimetres. And so you've got lots of different things happening here. So the volume is going to be the area of the roof times the height, but all need to be in centimetres since 1 centimetre cubed equals 1 millilitre. So we know that 1 centimetre cubed equals 1 millilitre. The hard thing here is that they're all in different units. So I'm going to change them all to centimetres and then go from there. So here I've drawn the roof. The roof is 400 metres squared. Now I don't know what it is really. 400 meters squared, it's a rectangular roof. So I know that that is 40 meters by 10 meters. 40 by 10 is going to give me the 400 meters squared. I want to change it to centimeters. It is not, there's 100 centimeters in a meter, therefore you times by 100. As soon as we go to centimeters squared, it changes. Centimeters, how many centimeters cubed in a cubic meter? It's not 100. So as soon as we get different things, it's hard. I can never remember them, so I never ask the students to remember them. I've set this up. 40 meters is 4,000 centimeters. 10 meters is 1,000 centimeters. So that's what I've done there. So suddenly I know that 400 meters squared is 4,000 times 1,000. So 4,000 times 1,000 times 2. Now, where did I get that 2 from? Why have I times it by 2? I've times it by 2 because 20 millimeters of rain fell. So there's 2 centimeters. So now they're all in centimeters. I've changed this 400 meters squared into this. So 400 meters squared is really, what is it? 4 million centimeters squared times 2. That's 8 million milliliters. Okay, so how much does the tank hold? It said it held 90,000 liters. This is in milliliters. So we're really mucking around with units here. How do we go from milliliters to liters? 1,000. There's 1,000 milliliters in a liter. So if we get rid of 1,000 here, that's going to be 8 million liters becomes 8,000. 80 million milliliters becomes 8,000 liters. So there's plenty. Is it going to overflow? 8,000 litres isn't really going to touch this at all. So the answer there, how many litres of water were collected? 8,000 litres of water was collected. Okay, but a really hard question. Always a band 6 when you have to muck around with units. They like doing that in the HSC, making you convert meters squared or meters cubed to centimeters squared. It is not the simple deal of just timesing by 100. In this case, 4 meters squared would have become 400 meters squared would have become like, 4 million centimeters squared. So it's a lot different to that. Okay, hopefully that has cleared things up a bit. Thanks.